My name is Ken Duda. I run the software team at Arista, one of the co-founders. What I really want to focus on is the foundational piece of what Doug was talking about, because what we're trying to accomplish here is create an environment, create an infrastructure where all of our customers can take advantage of what the world's top cloud companies are already doing in their continuous delivery, continuous rollout, continuous testing, continuous monitoring systems. Get away from the world where people upgrade their switches once every 7 years. How can you do that and also be responsive to the security threat situation, right? You need to have a much more rapid ability to deploy new software, do it much more frequently. And the foundational piece is you can only do that if you have confidence that the software that you're deploying is actually going to work. But unfortunately, our customers have been trained by our competitors that that's simply not the case. And that when the new release comes out, yeah, it fixes some bugs, it introduces some new ones, and even some bugs that were fixed before have come back. How can this be? What can we do about it? So it all starts, the most fundamental layer, with quality. And quality comes from three places. Quality comes from architecture, it comes from how you test, and it comes from the culture of your organization. Starting with architecture. Our competitors have built sprawling architectures of lots of processes and subsystems with all sorts of arbitrary ad hoc communication primitives, passing messages, building up big queues, interactions that no one can fully understand, creating dynamics that lead to crashes, and if one process goes down, it ripples and affects everything else. And we took a different approach. We separate out the state from the processing, put all the state in one place, sort of like some newer systems do, like Kubernetes, for example, right? The state of your Kubernetes pods, your Kubernetes cluster, exists in etcd. And it's safe from the behavior of all the individual machines. Likewise, in EOS, which is of course designed before Kubernetes even existed, we have all of our state in a central system database, with the different processes running around that in isolation from each other, no direct interactions, but interacting only through reads and writes to that database. This creates a situation where one process can't even tell that another process went down. You don't know that that happened. And that means any process can be individually stopped, started, restarted, debugged, traced, or patched and upgraded. And so we use this both to tolerate software bugs, so bugs that can be severe in other competing architectures are invisible to the customer in our architecture, but also enabling what server administrators have done for years. You go to a server guy and say, hey, guess what? Did you know you could upgrade HTTPD on your server without upgrading the name server also? It's like, yeah, of course. I can upgrade one RPM but not another. Like, where's the news there? Well, good luck doing that on your network, right? But with EOS, we can do that, and we provide patches, especially for critical security problems that are installed live and completely non-disruptively. So architecture really matters for quality, but more important than architecture is how you test. We've made a tremendous investment in fully autonomous testing. From day one, as head of software, I insisted that every engineer deliver two things together. One, the code for the new feature, and two, a set of fully autonomous test cases that prove the feature works. And by fully autonomous, I mean running 24/7 with no human involvement, where software decides which branch to build. Software builds the code. Software runs all the unit tests. You now have a unit tested image. That all happens before it gets loaded onto a switch. Then if it passes the unit tests, software decides which test bed to load the image onto. Loads the image, and then software decides which tests to run based on a database of past results and test priorities. Software runs those tests. And then if they pass, that's great, records the result in the database. If it fails, then software matches the failed test log against fingerprints of known issues. If there's a hit, annotate the bug. Mr. Engineer, happened again, right over here, better come take a look, right? If there's no hit, then the failed test log goes onto a queue of unexplained test failures, where an outsourced group looks over the log, tries to understand what's distinctive about this failure. If the switch were to fail again in the same way, how would you know? They then open a bug describing the symptoms, create the fingerprint to map similar failures to that bug, and then go on to the next failure. And with this apparatus, we can run every test case for every product feature on every hardware platform for every software release, including all of our maintenance releases. And that massive automation effort goes on in parallel with traditional human-driven testing, which is actually really important because with all the automation in the world, you still only catch the things that the computer's looking for. Humans catch stuff that computers don't always notice. And that's a very important partnership between our human testers and our robot testers. I wish I could look you in the eye and say, when you test this way, you never have any bugs. But it's not true. We've had bugs. Whenever we add new features, we add new bugs along with them, and including breaking stuff that used to work. But where this system has been tremendously effective as it's essentially eliminated maintenance regressions. What I mean by that is something that used to work getting broken in a maintenance release. Single digit in the history of Arista, shipping software now for over 10 years. Because of this massive investment in test automation and also other advantages I'll come to in a minute. Because more important than testing is the culture of the organization. And by culture, I mean, what do you believe in? What drives your organization? How do you make trade-offs? What do you talk about to your team? What governs the way engineers make their decisions? And at Arista, we are 100% consistent. Quality is the most important factor. It's more important than features. It's more important than new platforms. It's more important than schedules, because I'd rather apologize 100 times for not having some feature the customer wants or missing some date on some release than apologize even once for melting down somebody's network. Networks are too important. Why do other vendors treat them like, oh, well, we'll just get to the next thing, we'll fix it later. You know, it's not good enough. Second, the software team is responsible. Other companies have a quality assurance team whose job is to assure the quality, which is impossible because software is full of dark corners. The QA team doesn't even know where they all are. But even if they knew, once the software has been fully compiled, linked into an image, loaded onto devices, you lack the tools to drive the software into those dark corners. At Arista, the software team is responsible for quality, and the test team helps catch our mistakes. But that's also where another principle is when you do have an escape, whether it's caught by a customer or caught by our test team, every fix includes the new automated test, right? Because anything that gets to even our test team, let alone a customer, had to get through all of our automated tests first. How did that happen? So we have to create a fix for the bug and also create the new test. So year after year after year, this sort of screen of automated tests between our engineers' buggy fingers and our customers' networks gets thicker every year. And as our install base has grown, our use cases have grown, as our products have grown more complex, as our number of customers has grown, customer cases due to bugs on a per install base basis falls every year. And that's, I believe, because of the culture of quality. Customer issues trump new development at Arista. That means that if the customer is having an issue with our switches, they're not working properly, my instructions to my team, the software team, are, hey guys, trust me, whatever you're working on, it can wait. Put that down, go help in the field, right? This is not how it works at our competitors. At our competitors, there's always a business trade-off because the engineer is on a critical feature for some big customer. How big is the customer with the problem? Do we really need to go look at that now? Can't we look at that later? Not here. Doesn't matter size of the customer. It could be the smallest customer we've ever had. And I'm thinking my lucky stars. Go jump right on that case, get that thing fixed, get that fix rolled out in my maintenance trains because we're on borrowed time. It's just a matter of time until that same bug takes out one of our top 10 customers. What are you waiting for? So customer issues always come first. Customers love they like our software, they love our support. And as a software guy, I'm always a little jealous. Like, I wish they liked our software as much as they like our support. But I can take some comfort in the fact that one of the reasons I believe customers like our support so much is the software team really has their backs, right? So the culture of quality is how we've managed to create an environment where customers can deploy our code with confidence. How do I know that before I get there, I want to talk about what happens at some of our competitors when you don't prioritize schedule, when you don't prioritize quality over schedule. Because most engineering groups are driven to deadlines, right? That's the number one thing, is hitting your dates. And look, I'm not saying that any of our competitors are deliberately shipping garbage code just to hit their schedule and get their bonus or anything like that. It's not that. It's not like that. But it leads to other issues. So one thing that customers have really wondered is, why do these bugs come back? Why is it that a bug is fixed in one release, and then you deploy a later release, and the bug is back? Let me show you what happens. You show up to work one day, and you update your tree, and all support for your platform is gone. Whoops. Oh, guess I'm not working on that today. Oh, wait, where's my code? Oh, well, you poke around a bit, and don't worry. So what happened here is we pulled a branch, you see, because we're working on this really important new switch, and it's business critical to ship this on time, meaning my boss doesn't get his big bonus unless we ship on time. So the software schedule is coming in 3 weeks late. What are we going to do? Oh, we figured if we just pull a branch, which means copying and pasting the entire code base, right? We pull a branch, and then we can do the work for our platform on this branch. We can hack it in wherever it needs to go. We don't need to worry, platform dependent, platform independent. It's just our platform. We don't need to worry about all the integration testing with other platforms. We'll save probably 6 or 8 weeks on the schedule. Oh, you'll save 6 or 8 weeks. That's great. And then you're going to merge these branches back together again, right? Oh, merge them back together. Yeah, sure, of course. As soon as we have time. So off you go, and you go ahead and ship your release, and that's great. You shipped it 6 weeks early. Congratulations. Except when you pulled that branch, you realize that was in the middle of a dev cycle. You cut and pasted probably 10,000 bugs. There's now 2 copies of every bug. So you discover some bug, and that same bug is on the other branch too. And you fix it, and you got to port the fix over. And it ports over pretty clean. You patch it. There's a few conflicts. The code's only diverged a little. You're pretty comfortable with that, and you go ahead and ship, and so far so good. But then you discover another bug, which is also in both places. So this time, when you go ahead and make the fix in the other branch first, you try to port it back. There's a whole bunch of conflicts because the code is diverged, and you put it back together as best you can. But when you do that, you accidentally mess it up and delete the fix for the first bug. It's now back. And because you lack the test automation, you didn't add that automated test that verifies that fix is in place. The next thing that happens, it goes straight to your customer, blows up their network. Sorry, it's apology time again, right? And this is such a disaster. And the solution to this is actually pretty simple. It's 2 parts. The first part is, don't do this. One EOS trunk, right? All new feature development is in one place. And that one build produces an image that runs across all of our switches. This is also why, by the way, you may have noticed with some vendors, you have a different build or a different image on every line of switches, right? Why is that? The software is kind of almost the same, right? It's because of all these branches, all with their own unique set of bugs. It's such a quality disaster. So don't do that. It does mean that sometimes you ship 3 weeks later, right? Because you had to actually do all that integration work up front. But you're in so much of a better place because now, with all your code in one place, you're not creating copies of all these bugs. You're not having to chase them all down separately. Plus, your customer has only one image to deal with, one image to deploy, one image to qualify across the whole fleet. It's a dramatic simplification for customers as well. And then the other part of the solution, of course, is the automated testing. That because when we had the escape, we created the new test, even if we introduce the same problem for a different reason, our test will catch it. So the same problem cannot escape a second time. So that's how we've solved this problem. And the result of this is that you can now deploy releases with confidence. How do we know we're doing better? If you're thinking about me for Christmas, what I really want is a switch quality meter, right? Open the door, put the switch in, press the button, and the bam, 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 warning, do not deploy. I don't know how to build something like that. So I don't know how to compare apples to apples versus other switches in the industry. But we do talk to a lot of customers. And from customer conversations, I'll tell you, we're not 10% better or 50% better. It's more like 90% better. And the feedback from account teams and support engineers is the same thing, right? Salespeople at Arista tell me they're happier here than they've been anywhere in their career because they can spend their time selling, whereas in their previous job, 50, 60, 70% of their time on escalations, swapping out gear, release selection, apologizing, bug scrubs, all that stuff around quality problems. And account teams hate it. They are right with me on this. The salespeople who need to make their numbers and they need to close deals and they need all the latest features to do that are 100% consistent. Yes, Ken, we want everything yesterday, but never sacrifice quality, because quarters come and go. Customer relationships are forever. And so the feedback from account teams has been crystal clear. But my favorite source, of course, and you've already seen this graph, is the public CVE data. And look, I understand not every bug is a CVE, but every CVE is a bug, right? And that graph, I think, shows you the kind of shape of the difference between what we've achieved in the quality department compared with certain other companies.
What is the source of this data?
This is from the CVE details. Yeah, Doug, you want to?
It's from the U.S. National Vulnerability Database, maintained by MITRE.org under contract to the Department of Homeland Security.
This U.S. government data. Yeah. Yeah. So if there were a third party, like a neutral, independent database of like all the bad bugs that take out networks, not just the security ones, that would be really great, because that would be a lot of fun to compare with. Unfortunately, there is no such database that I know of. So the mission here is how to get to our customers some of the benefits that the world's largest cloud operators have gotten through their continuous deployment processes. This is about what Doug was talking about raising the level of your operational game, a higher operational maturity level, where you're rolling out validated changes continuously, monitoring them, getting that whole feedback loop going so that you can keep a complex system evolved, moving forward all the time, so it doesn't get stuck, siloed, frozen in time, and then vulnerable to a whole host of problems. So how do we enable continuous deployment? So what we've done is organized our releases into trains. And the idea is that on the release train, the first few releases come out with new features. If you need the features, then you need the release. And if you don't need the feature, then ignore the release, okay? And then after that, the feature releases come out. The next release on the train will be a maintenance release. And the maintenance release is our commitment to you that the only changes in that release are narrowly targeted fixes to important quality issues, and that all subsequent releases on that train will also be maintenance releases. And so that's where we'd like you to deploy. And then new features will go on the next train. So as we deploy new maintenance releases, we would like you to stay at the tip, the most recent maintenance release of the train that has all the features you need. Not my latest code. My latest code is down there with new features. If you need them, you need them. But if you don't, don't take them. Stay on that maintenance train. If it's my network and my butt's on the line to keep that thing up and running, and Arista comes out with a new maintenance release on the train I'm already running, it's not a question of if, it's just a question of when am I going to deploy that into my network, because I know that Arista has fixed 30, 40, 50 bugs, has not introduced new ones. My chances of getting burned by holding still are 20 times my chances of getting burned by some new maintenance regression if I update. We have data that supports that. So what we're doing to try to help you is providing you with these maintenance trains with images that run everywhere, a single image across your whole fleet, giving you fixes without new bugs, live patches for critical issues, and tools for automating the whole process, for automating knowing when you need to upgrade, why you need to upgrade, for automating the validation of that, for automating the actual rollout of those releases, and then automating the ongoing monitoring to make sure things are working as you expected. So our ask from our customers, from you, is to try to evolve so you can practice continuous deployment. I do believe the number one thing we can do to further improve our customers' quality experience with our product is get them to practice this kind of continuous deployment. Stay at the end of your maintenance train. Don't waste your time qualifying the next release of the train, right? If you've already qualified one of those green guys, the next one is there's no point in requalifying that. It's just a waste of your time and energy. And by the way, some customers are taking me up on this, right? They've decided that we've been so reliable here, they're going to trust me on this, which is great. Not all customers do, but I think we'll get there as we increase our operational maturity. Don't move to the next train unless you need the new features, the new platform support, and make that investment in automation, whether it's a homegrown thing, whether you're using something like Ansible open source, whether you're using CloudVision. I think CloudVision does a great job of this, but the important thing is to automate this so that it's really happening on a continual and ongoing basis.